From the dawn of humankind, we have gazed up at the night sky, our eyes drawn to the twinkling points of light that adorn the celestial tapestry. Among these celestial wonders, one object has held a particular allure: Mars, the red planet. Its fiery hue has sparked countless myths and legends. Ancient civilizations wove tales of gods and monsters associated with Mars, its reddish glow often interpreted as a sign of war or ill omen. The Romans named the planet after their god of war, Mars, yet they couldn't help but be captivated by its mysterious beauty. As our understanding of the cosmos grew, so did our fascination with Mars. With the invention of the telescope, we could observe the planet in greater detail. What we saw only deepened our intrigue. Giovanni Schiaparelli's observations revealed what he believed to be a network of canals. While later observations proved Schiaparelli's canals to be an optical illusion, the seed of possibility had been planted. Could there be life on Mars? Could we, perhaps one day, journey to this alien world and unlock its secrets? These questions have continued to drive scientific inquiry and capture the public imagination for generations. The allure of Mars has extended far beyond the realm of science, permeating our popular culture and shaping our dreams of what lies beyond Earth. From H.G. Wells's chilling depiction of Martian invaders to Ray Bradbury's The Martian Chronicles, science fiction has embraced Mars as a canvas for exploring the unknown. These stories have shaped our perceptions of Mars and fueled our desire to explore this alien world. What was once confined to science fiction is now scientific possibility. Advancements in space technology have allowed us to study Mars in detail. Orbiters have mapped the Martian surface, revealing towering volcanoes, vast canyons, and ancient riverbeds. Robotic rovers have traversed the landscape, collecting data about the planet's geology and atmosphere. These missions have provided a wealth of information, painting a clearer picture of Mars's past and present. Mars may have once been a warmer and wetter planet, potentially capable of supporting life. This realization has intensified our desire to unlock Mars's secrets and determine if we are alone in the universe. The dream of setting foot on Mars is now a tangible goal within our reach. The question is no longer whether Mars has captivated our imagination, but rather how we will turn our celestial dreams into a tangible reality. The red planet beckons as a potential second home for humanity. The challenges of reaching Mars are immense. The thin atmosphere, extreme temperatures, and harmful radiation are significant obstacles, yet the spirit of exploration burns brighter than ever. Space agencies and private companies are developing the necessary technologies. From powerful rockets to innovative life support systems, the pieces are falling into place. The journey to Mars will test our ingenuity and courage, but it is a journey we are ready to take. In exploring Mars, we seek to understand ourselves. The solar system offers a diverse array of celestial bodies, each with unique characteristics. Among these wonders, Mars stands out as a beacon of possibility, a potential second home. Mars captures the imagination and offers potential for human habitation. Its similarity to Earth is evident in its fundamental characteristics. Mars occupies a Goldilocks zone with conditions not too extreme for life. Evidence suggests Mars was once warmer and wetter, potentially harboring life. This glimpse into Mars's past fuels speculation about life beneath its surface. The allure of Mars extends to its potential as a second home for humanity. Imagine a future where we establish a permanent presence on Mars. Imagine waking up on Mars, the reddish hue of the landscape filtering through the windows of your habitat. As you step outside, you're greeted by a vista unlike anything on Earth, a world of towering volcanoes, vast canyons, and ancient riverbeds. This is the allure of Mars, a planet that promises not only survival, but also a life of adventure and discovery. A Martian day, known as a sol, is just over 24 hours long, only slightly longer than an Earth day. This similarity in day length would make it easier for humans to adapt to the Martian environment. The Martian year, however, is significantly longer, lasting 687 Earth days. This means that seasons on Mars are also longer, with each season stretching out for nearly twice as long as on Earth. This has significant implications for future human settlements, influencing agricultural cycles and weather patterns. Mars is a dynamic planet with its own unique rhythms and cycles, much like our own. Water, the lifeblood of our planet, is also a key factor in our search for life beyond Earth. Mars holds the promise of water, both in its past and potentially its present. Evidence of ancient riverbeds and water ice at the poles points to a time when liquid water flowed freely. This discovery has profound implications for the search for life on Mars. Water ice on Mars is crucial for future human missions, providing a sustainable source for drinking, agriculture, and rocket fuel. Imagine a future where human settlements on Mars are powered by Martian water, propelling explorers further into the cosmos. In the vast expanse of our solar system, reaching out to other planets presents formidable challenges. Mars stands out as a relatively accessible destination, its proximity offering a unique advantage in our quest to explore beyond Earth. Compared to other potentially habitable worlds, Mars is a stone's throw away, astronomically speaking. This proximity translates into shorter travel times, reducing the risks and challenges associated with long-duration spaceflight. These launch windows occur approximately every 26 months, offering more opportunities to send missions to Mars. The allure of Mars extends beyond the planet itself. It represents a crucial step in humanity's journey to become a multi-planetary species. By establishing a presence on Mars, we secure our future beyond Earth. Mars could serve as a hub for future space exploration. The technologies developed would prove invaluable as we venture further. Imagine spacecraft from Mars embarking on journeys to the outer planets. Colonizing Mars marks a shift to becoming a spacefaring civilization. The challenges are undeniable, but the rewards are immeasurable. It is a challenge worthy of our best efforts. In reaching for Mars, we are reaching for our future. The Martian atmosphere, a wisp of gas compared to Earth's, presents a daunting challenge to human survival. Composed primarily of carbon dioxide, the Martian air is too thin to breathe, requiring enclosed habitats. This thin atmosphere provides minimal protection from space. Unlike Earth, Mars's atmosphere offers little respite from harmful radiation. Constant exposure to radiation poses significant health risks. Mars lacks an insulating layer, resulting in extreme temperature swings. This variation challenges human survival and equipment operation. The average temperature on Mars is a bone-chilling minus 63 degrees Celsius, far colder than even the most extreme environments on Earth. This extreme cold is due to Mars's distance from the Sun and its thin atmosphere. The relentless cold poses a constant challenge to human survival. Future colonists will need specially designed suits with advanced thermal regulation. These suits must be lightweight, flexible, and well insulated. The extreme cold also presents engineering challenges for infrastructure. Essential systems need insulation and heating to prevent freezing. Heated greenhouses are necessary for agriculture in the frigid Martian soil. Section 3. The invisible threat: radiation. Mars presents an insidious threat to human health: radiation. Unlike Earth, Mars offers little shielding from cosmic rays and solar radiation. This poses a significant risk, potentially leading to cancer and other illnesses. Protecting future Martian colonists from radiation will be crucial. Habitats will need radiation shielding, using Martian soil or water ice. Addressing radiation is key to ensuring the viability of human presence on Mars. Section 4. A world of dust and storms. The Martian surface, a desolate expanse of red dust and rock, holds a hidden danger: dust storms. These storms can engulf the entire planet, blocking out the sun and transforming the landscape. Martian dust, fine as talcum powder, poses a significant challenge for explorers and equipment. This fine dust can infiltrate crevices, jamming parts and scratching surfaces. Dust storms reduce sunlight, impacting solar power generation. Communication with Earth could be disrupted, isolating colonists. Developing dust-resistant materials and robust systems is essential for a sustainable presence on Mars. Section 5. The isolation of a distant world. The vast distance between Earth and Mars presents a unique psychological challenge for any future Martian colonists. Isolation. Communication delays ranging from several minutes to 22 minutes would alter the nature of communication. This isolation, coupled with confinement, could take a toll on the mental and emotional well-being of Martian colonists. Addressing these psychological challenges will be crucial for maintaining the well-being and morale of any future Martian colony. Section 6. The human factor, psychological resilience. Venturing to Mars tests human resilience, adaptability, and the spirit of exploration. Beyond physical challenges, psychological hurdles are significant. Confined living conditions demand exceptional psychological strength. Coping with stress in close quarters is crucial. Adaptation to Mars's unique demands is vital for well-being. Resourcefulness and a positive attitude are essential. Fostering community and purpose maintains morale. Shared goals and personal growth counteract isolation. Investing in psychological well-being ensures thriving on Mars. From dreams to blueprints. For generations, the dream of reaching Mars has captivated our imaginations. What was once confined to imagination is now transitioning into possibility. We are developing technologies, designing missions, and training astronauts. The blueprints for Mars colonization are being drawn up in labs and space agencies. We are developing rockets capable of carrying humans to Mars, designing habitats for a safe and sustainable environment on Mars, learning to grow food, extract water, and utilize Martian resources. The dream of Mars colonization is now a tangible goal within our reach. Section 2. Pioneering the path, NASA's Mars endeavors. At the forefront of this ambitious endeavor is NASA, the United States Space Agency. From the early Mariner and Viking missions to the more recent rovers like Curiosity and Perseverance, NASA has consistently pushed the boundaries of our understanding of Mars. Building upon this legacy of exploration, NASA is now actively developing the capabilities needed for human missions to Mars. The SpaceX equation, a bold vision for Mars. SpaceX, led by Elon Musk, aims to establish a self-sustaining city on Mars, making it a second home for humanity. Central to this plan is the Starship spacecraft, designed to transport humans and cargo to Mars. SpaceX envisions a fleet of spacecraft carrying everything needed to establish a permanent human presence. This includes infrastructure, equipment, and resources for a self-sustaining colony. Section 4. Life support, breathing life into the red planet. One of the most critical challenges for any future Mars colony will be creating a self-sustaining life support system, a closed-loop ecosystem that can provide essential resources like oxygen, water, and food without relying on constant shipments from Earth. Fortunately, significant progress is being made in developing the technologies needed to make this vision a reality. Oxygen, essential for human respiration, is scarce in the thin Martian atmosphere. However, scientists are exploring several promising methods for generating breathable air on Mars. One approach involves using electrolysis to split water molecules extracted from Martian ice into their constituent elements, hydrogen and oxygen. Another approach involves utilizing Martian resources, such as the abundant carbon dioxide in the atmosphere, to produce oxygen through chemical reactions. Water, the elixir of life, is another crucial resource that will need to be readily available on Mars. Fortunately, evidence suggests that vast reserves of water ice exist beneath the Martian surface, as well as in the polar ice caps. Developing efficient and reliable methods for extracting, purifying, and recycling water will be essential for sustaining a human presence on Mars. Waste management, often overlooked, is another crucial aspect of a closed-loop life support system. Developing efficient methods for composting organic waste, recycling gray water, and even utilizing human waste as fertilizer will be essential for minimizing waste and maximizing resource utilization on Mars. Section 5. Martian Gardens, cultivating sustainability. Imagine strolling through a lush greenhouse on Mars, bathed in the warm glow of artificial sunlight, surrounded by rows of leafy green vegetables, vibrant fruits, and fragrant herbs. This vision, once relegated to the realm of science fiction, is now within the realm of possibility, thanks to ongoing research and experimentation in the field of Martian agriculture. While the Martian soil, lacking in organic matter and exposed to harsh radiation, presents challenges for traditional agriculture, Scientists have demonstrated that it is possible to grow plants in Martian regolith with the addition of essential nutrients and shielding from radiation. Experiments have shown that crops like lettuce, radishes, and even potatoes can be successfully cultivated in simulated Martian conditions. Hydroponics, a method of growing plants without soil, using nutrient-rich water solutions, offers another promising approach for food production on Mars. This method requires less water and space than traditional agriculture and can be easily controlled within a closed environment, making it well-suited for the Martian environment. In addition to growing crops, future Martian colonists may also cultivate algae, fungi, and insect protein as alternative food sources. These organisms can provide essential nutrients and protein with a smaller environmental footprint than traditional livestock, making them viable options for supplementing the Martian diet. Section 6. Building a new home. Martian resources take center stage. Imagine a future Martian city, its structures gleaming under the pale pink sky, not as stark outposts but as a testament to human ingenuity and resourcefulness. These structures, built not from materials shipped at great cost from Earth but from the very fabric of Mars itself, represent a key step towards a self-sustaining human presence on the red planet. Martian regolith, the loose, unconsolidated rock and dust that covers the planet's surface, holds the key to unlocking this potential. Scientists and engineers are developing innovative techniques to utilize regolith as a building material, transforming it into durable bricks, tiles, and even concrete-like substances through processes like sintering, melting, and three-dimensional printing. This Martian concrete, stronger than its earthly counterpart due to the binding properties of Martian dust, can be used to construct habitats, landing pads, and other infrastructure, minimizing the need to transport heavy building materials from Earth. The reddish hue of the regolith would lend a distinctive Martian aesthetic to these structures, creating a visual connection to their surroundings. Water ice, abundant beneath the Martian surface, can be melted and combined with regolith to create a mud-like substance suitable for constructing shelters and other structures using ancient building techniques like rammed earth construction. This method, utilizing readily available Martian resources, offers a sustainable and cost-effective approach to building on Mars. Guardians of another world. As we venture further into the cosmos, driven by curiosity and the allure of new frontiers, we carry a responsibility to protect the celestial bodies we explore. This lies at the heart of planetary protection, preserving the pristine nature of other worlds. Mars, with its hints of past habitability, presents a unique challenge. The discovery of microbial life on Mars would be monumental, altering our understanding of life in the universe. Section 2. The Terraforming Debate, Reshaping Mars in Our Image. The allure of Mars colonization extends beyond simply establishing a foothold on another world. It encompasses a bolder, more ambitious vision: terraforming, the hypothetical process of transforming Mars into a more Earth-like planet, capable of supporting human life without the need for artificial habitats or protective suits. While this concept has captivated science fiction writers and futurists for decades, it raises profound ethical and philosophical questions that warrant careful consideration. Proponents of terraforming argue that it represents the ultimate act of environmental stewardship, transforming a hostile and barren world into a habitable oasis for life. They envision a future Mars with a breathable atmosphere, flowing rivers, and verdant landscapes, a testament to human ingenuity and our ability to reshape entire planets to our liking. However, terraforming also raises significant ethical concerns. Critics argue that it represents a form of cosmic arrogance, an attempt to impose our will on another planet without fully understanding the potential consequences. They question whether we have the right to fundamentally alter another world, potentially disrupting any existing Martian ecosystems, even if those ecosystems consist only of microbial life. Moreover, the technological challenges of terraforming are immense, requiring technologies that are currently beyond our capabilities and likely to remain so for centuries to come. The energy requirements alone would be astronomical, requiring the harnessing of vast amounts of energy from the sun or other sources. As we contemplate the prospect of establishing a permanent human presence on Mars, a new set of ethical and philosophical questions emerges, questions that delve into the very nature of society, governance, and the rights of future generations. These future Martians, born and raised on a different planet, facing unique challenges and opportunities, will likely develop their own distinct culture, identity, and aspirations. What kind of society will they create? Will they model their governance structures and social norms after those of Earth, or will they forge a new path, informed by the unique challenges and opportunities of their Martian environment? Who will have the right to represent Mars in interplanetary affairs? Will Mars be considered a colony of Earth, or will it strive for independence, charting its own course among the stars? The ethical imperative extends to ensuring that future Martians have the same fundamental rights and freedoms as those of us on Earth. This includes the right to life, liberty, and security of person, the right to freedom of thought, expression, and assembly, and the right to education, healthcare, and a healthy environment. Moreover, we must consider the intergenerational implications of our actions. What legacy will we leave behind for future Martians? Will they inherit a thriving and sustainable society, or will they be burdened with the consequences of our short-sightedness and greed? Imagine gazing back at Earth from the surface of Mars, a tiny blue marble suspended in the blackness of space, its continents barely discernible, its bustling cities reduced to pinpoints of light. This awe-inspiring perspective, known as the overview effect, has profoundly impacted astronauts who have witnessed it firsthand, instilling a sense of interconnectedness, a deep appreciation for the fragility of our planet, and a renewed commitment to global unity and environmental stewardship. For future Martians, this perspective would be ingrained in their very being, shaping their worldview and influencing their values. Living on a planet where resources are scarce, where the environment is unforgiving, and where the interconnectedness of all living things is readily apparent, would likely foster a deep sense of environmental awareness, a culture of conservation, and a strong emphasis on cooperation and community. The Martian perspective, unburdened by the historical baggage and geopolitical divisions that have plagued Earth for millennia, could offer a fresh perspective on humanity's challenges and opportunities. It could inspire new approaches to conflict resolution, resource management, and environmental protection, approaches that prioritize global cooperation and the long-term well-being of both humanity and our planet. The allure of Mars colonization runs deeper than simply the pursuit of scientific knowledge or the desire to escape Earth's problems. It speaks to a fundamental aspect of the human spirit, a deep-seated need to explore, to push the boundaries of our knowledge and capabilities, and to venture into the unknown, driven by curiosity, a thirst for adventure, and a desire to leave our mark on the universe. Throughout history, humans have migrated, explored, and settled new lands, driven by a restless spirit and a desire to expand our horizons. From the early Polynesian navigators who crossed vast oceans in outrigger canoes to the explorers who charted new continents, the urge to explore is deeply ingrained in our DNA. Mars, with its challenges and its promise, represents the next great frontier, a blank canvas upon which we can write a new chapter in human history. It is a challenge that calls upon our ingenuity, our courage, and our collective spirit of adventure. A challenge that has the potential to unite humanity in a common goal, pushing the boundaries of technology, science, and the human spirit. Section 6. A mirror to ourselves. Learning from Mars, reflecting on Earth. The endeavor of colonizing Mars, while focused on another world, offers a unique opportunity for introspection, a chance to reflect on our own planet and our place within the grand tapestry of the cosmos. By studying Mars, its history, its geology, and its climate, we gain a deeper understanding of Earth, its evolution, and the delicate balance of systems that make life possible on our planet. The challenges we face in colonizing Mars, from developing sustainable life support systems to managing limited resources, serve as stark reminders of the importance of environmental stewardship and the need for sustainable practices here on Earth. The lessons learned from building a self-sustaining colony on Mars could provide valuable insights into how we can better manage our resources, reduce our environmental impact, and create a more sustainable future for all. Moreover, the endeavor of colonizing Mars has the potential to unite humanity in a common goal, transcending the political, social, and economic divisions that have long plagued our species. The challenges of establishing a human presence on another planet would require global cooperation, fostering a sense of shared purpose and reminding us that we are all part of one human family, sharing a common destiny on this fragile planet we call home. Section 1. The Next Giant Leap. The journey to Mars, once a distant dream confined to the pages of science fiction, is now tantalizingly within reach. Driven by technological advancements, a renewed spirit of exploration, and the collective ingenuity of scientists, engineers, and dreamers around the world, we are steadily transforming science fiction into scientific reality. The question is no longer if we will reach Mars, but when and what will we find when we get there. The challenges are undeniable. From the technical complexities of designing spacecraft and habitats capable of withstanding the rigors of interplanetary travel and the harsh Martian environment, to the ethical considerations of planetary protection and the rights of future Martians. Yet, the potential rewards are immeasurable. Mars beckons, not as a distant alien world but as a frontier ripe for exploration, a blank canvas upon which we can write a new chapter in human history. It is a challenge worthy of our best efforts. A challenge that calls upon our ingenuity, our courage, and our collective spirit of adventure. Section 2. Shaping the future, one step at a time. The path to Mars is not a straight line. It is a journey of incremental steps, each building upon the last, each pushing the boundaries of our knowledge and capabilities a little further. From the early robotic missions that have paved the way, providing invaluable data about the Martian environment, to the development of powerful rockets and spacecraft capable of carrying humans to Mars and beyond, we are steadily overcoming the technological hurdles. The next decade will be a pivotal time in Mars exploration. We can expect to see a flurry of activity, with robotic missions continuing to explore the Red Planet, paving the way for human explorers. We will witness the testing and development of new technologies, from advanced life support systems to innovative propulsion methods, that will make human missions to Mars safer, more affordable, and more sustainable. The first human footprints on Mars will mark a profound moment in human history, a testament to our indomitable spirit of exploration and our relentless pursuit of knowledge. But it will be just the beginning. Section 3. A New Dawn for Humanity. The colonization of Mars, the establishment of a permanent human presence on another world, represents a profound paradigm shift for humanity. It is a step towards becoming a multi-planetary species, a safeguard against the existential threats facing our own planet, and an opportunity to create a new society free from the constraints of Earth's history and baggage. The endeavor of colonizing Mars will undoubtedly test the limits of our technology, our ingenuity, and our resolve. But it is a challenge we are ready to embrace, for it speaks to something deep within the human spirit, a yearning to explore, to discover, and to push the boundaries of what is possible. As we stand on the cusp of this next giant leap for humanity, we do so with a sense of awe, excitement, and a profound responsibility to shape a future worthy of the generations that will follow in our footsteps. The Red Planet beckons, and we are ready to answer its call.